Alright, so today I want to go over section 7.2, Trigonometric Integration. So after going over integration by parts in 7.1, we're going to talk about trigonometric integration. So we're going to learn how to integrate something like this. Integral of sine to the power mx cosine nx dx. And we're going to learn how to integrate tangent to the power mx dx, secant nx dx, where m and n are non-negative integers. In the process, we're going to need the identities. So identities to remember, trig identities. The double versus half angle formula, sine square x is 1/2 into 1 minus cos 2x, and cosine square x is 1/2 1 plus cosine 2x. Okay, these are from trig. So for example, just to give you an idea, as a warm-up, if I say evaluate the integral of cosine square x dx, well, we know that that's cosine square 1/2 1 plus cosine 2x dx, which can be split up into 1/2 integral of dx plus 1/2 integral of cosine 2x dx, which would be 1/2 x plus 1/4 sine 2x plus c, because integral of cosine 2x is 1/2 sine 2x. That's where this came from. So in general, what if I have integral of sine mx cosine nx dx? Is there a set of rules we can follow? Yeah, there is, and it's on page 15 in your notes, and I'm not gonna copy this, it's all in here. So we're integrating sine mx cosine nx dx. Okay, that's the procedure and the identity that we're gonna need. If n is odd, remember n in this case is the exponent of cosine. So basically what this means, if you're doing something like, if n is odd, so say you're doing something like sine square x cosine cube x dx, that's odd. Okay, split off a factor of cosine x, so you're gonna write this as sine square x cosine square x times cosine x dx. Apply the relevant identity. So you're going to do cosine square, you're going to change it into 1 minus sine square. And then you make the substitution u equals sine x. So if you do u equals sine x, then du is cosine x dx. And that would be integral of u square, 1 minus u square du, which can be easily integrated, which would be u cubed over 3 minus u5 over 5 plus c, and u is sine x, so it's sine cube x over 3 minus sine power 5x over 5 plus c. Okay, that's what this one means. Now the second case, if m is odd, so m, remember we're doing integral of sine mx cosine nx dx. So if this is odd, so like if you have here sine 5th x and anything there, cosine 4x or whatever that is, okay? So if m is odd, then split up a factor of sine, so you're going to do sine x times sine 4x cosine 4x dx. Apply the relevant identity, so sine square is going to be 1 minus cosine square, so this is actually sine square square. So you're going to write this as 1 minus cosine square x square, that's cosine 4x dx, and then let u equals cosine, and you're gonna be able to finish that. If m and n are both even, So say if you have sine 4x cosine 4x dx. Use the relevant identity, so you can do sine square x 1/2 into 1 minus cosine, or cosine square, or you can actually write this if they're the same power, then you could do sine x cosine x before, and then you could use that identity. Okay, we're gonna see examples, but that's what you need to do. So when you have sine to a power, cosine to a power, even one of them to a power, high power, you look at that, okay, and see if it's relevant. So if I'm doing example 1, where it says integral of cosine cube x dx. So if you look at the map, we have, there's no sign, so it's okay. We have n is odd, right? Cosine cube. So we're going to split it, a factor of cosines, integral of cosine square x cosine x dx. Apply the identity, that's 1 minus sine square. And then make the substitution u equals sine x. So du is cosine x dx. Neat. So this would be integral 1 minus u squared. Cosine x dx is du. So it's u minus 1/3 u cubed plus c, which is sine x minus 1/3 sine cube x plus c. Okay. That was not bad. Let's look at example 2. Integral of sine to the power 4x dx. If you look at the map, if n is odd, that doesn't apply. If m is odd, that's not odd. If m and n are both even, so we have sine 4x. So that's there. So we, because here actually cosine 0x, which is even also. Okay. So we can write this as sine square x square. We're gonna use the identity sine square is 1/2 1 minus cosine. So it's 1/2 1 minus cosine 2x square. Which would be 1/4, and then we're squaring what's on the inside. It's 1 minus 2 cosine 2x plus cosine square 2x dx. And we know that cosine square 2x is 1/2 1 plus cosine 4x. Again, whatever this angle is, that's double. So we're going to take this and put it in there. So we get 1/4 1 minus 2 cosine 2x plus 1/2 1 plus cosine 4x dx. So it's 1/4 integral of 1 minus 2 cosine 2x plus 1/2 plus 1/2 cosine 4x dx. So that's 1/2, that's 3/2. So it's 1/4 3/2 x. If we integrate, minus 2 divided by 2, so it's 1 sine 2x. And then 1/8 sine 4x plus c. Next one is example 3. Integral of sine to the power 4x cosine to the power 5x dx. So let's see. If n is odd, that's it. N is odd. Okay. So we're gonna split off a factor of cosine. So we're gonna write this as sine 4x cosine 4x, and then cosine x dx. Apply the relevant identity, so we're going to replace cosine squared 1 minus sine square. Remember, this is cosine square square. So this would be 1 minus sine square x square, which is 1 minus 2 sine square x plus sine to the power 4x times sine to the power x cosine x dx. Or we can actually, it's probably easier to leave it like this, because we're gonna let u equal sine, okay? So there's no need for that, sorry. So if we let u equal sine x, right, that's the next step. So du is cosine x dx, and this would be u to the 4, 1 minus u squared. We're gonna have to square it, but it's easier to square the u's than the sines. And then cosine x dx is du. So this is integral of u4, 1 minus 2u plus u squared. So that's u4 minus 2u5 plus u6 du. So 1/5 u5 minus 2/6 u6 plus 1/7 u7 plus c. So 1/5 sine to the 5th of x minus 1/3 sine 6 plus 1/7 sine 7th of x plus c. Pretty neat. u6, oh, I forgot to integrate. I messed up. Did I mess up? It's 2u squared. It should be, oh, I see. It should be 1 minus u squared. Please fix that. That's sine squared, so it's 1 minus u squared. So it's 1 minus 2u squared. That makes a big difference. Let me fix that. So forget that, okay? My bad. So I have, let me go back here. So I have integral of u4, 1 minus 2u squared plus u4 du, which is u4 minus 2u6 plus u8. So when we integrate, we get 1/5 u5 minus 2/7 u7 plus 1/9 u9 plus c, which would be 1/5 sine 5th of x minus 2/7 sine 7th of x plus 1/9 sine plus c. All right. So next one, when both of them are even, so like sine 4x cosine 4x dx. So that's the case when both of them are even. So use relevant identity to reduce powers. So I'm going to use sine x cosine x because I could write this as sine x cosine x to the power 4. So I'll write this as 1/2 sine 2x to the power 4, which would be 1/2 to the 4 is 1/16. We'll pull this out. It's a constant. Sine to the 4th power of 2x dx. And we already did that in example 2, right? Yep, I did that in example 2. So if I let this equal u, so u equals 2x, du is 2 dx. So I need a 2, I need a 1/2, so it's 1/32 integral of sine to the 4th u du, which from example 2, it will be 1/32, 3/8 u minus 1/4 sine u, sine 2u, plus 1/32 sine of 8x plus c. Again, refer to example 2 in the notes that we just did. All right, now if I'm integrating, that's page 18, the notes, tangent mx secant mx dx. We're going to need those either. Integral of tangent is ln of absolute value of secant, and integral of secant is ln of absolute value of secant plus tangent. So we're integrating tangent m secant n dx. If n is even, like secant squared or secant 4, you split up the factor of secant squared. Okay, so if you have secant 4, you do secant squared times secant squared, and you use this identity, and you let u equal tangent. For example, if you're doing the integral of tangent qx secant 4x dx, you write tangent qx secant squared x and secant squared x dx. And then you write this as secant squared is plus tangent squared. And then you let u equals tangent x, so du is secant square x dx. So we have secant square x dx, and that's tangent cube, so you integral u cube, and then secant squared is du, and then and secant square is 1 plus tangent square, so it's 1 plus u square du. Okay, and you can work it out. So if m is odd power of tangent, so if n is even, you split off secant square. If m tangent power of tangent is odd, then you split off secant tangent, and then you use u equals secant and use that identity. If m is even and n is odd, even, odd, and then the identity is that, and there's integration by parts if needed. So it's a little bit complicated for that one. Anyways, so let me go over some examples to demo all these steps. So example 1, integral of tangent square x secant power 4x dx. So let's see which one is this. If n is even power of secant? Yeah. Okay, so that's what we're gonna do. We're gonna split off a secant square. Okay, so if we split off secant square, so we're gonna write as integral of secant square x dx, and oh wait, that's not the one I'm looking at. Sorry. Yeah, let me rewrite this. Tangent square x secant or x dx. So we're gonna split off secant square. So we're gonna have tangent square x secant square x times secant square x dx, and then we're gonna write the identity secant square is 1 plus tangent square, so tangent square, and this guy is 1 plus tangent square, and then this guy is secant square x dx, and then we let u equals tangent, so du is secant square x dx, so we get u square 1 plus u square and then du, and this would be integral of u squared du plus u4 du, which is 1/3 u cubed plus 1/5 u5 plus c. This is not acceptable as an answer. You need to go back to the original. 1/5 tangent 5th x plus c. Alright, next example. We're doing integral of tangent cube x secant cube x dx. So we have an odd power of tangent, which is 2. If m is an odd power of tangent, split up secant tangent. So we're gonna do tangent square x secant square x, and then we want secant x tangent x. So we take one of each and put it together. Okay, and then use the relevant identity. Tangent square is secant square minus 1. So this is integral of tangent square, which is secant square minus 1, and then secant square, and then secant x tangent x. And obviously we let u equal secant because that's its derivative. Secant x, so du is secant x tangent x dx. So integral of u square minus 1 u square du, which is integral of u4 minus u square du. So 1/5 u5 minus 1/3 u cubed plus c. 1/5 secant fifth x minus 1/3 secant cube x plus c. Okay. Example 3. Integral of tangent square x secant x dx. This is the case where m is even and n is odd. Tangent of x is even and secant of x power is odd. Even, odd. So it use the relevant identity to reduce the integrand to powers of secant alone. Then use integration by parts if needed. So we're going to do we're going to change tangent there into secant square minus 1 because we want secant alone. And then we're going to write this as secant cube dx minus integral secant x dx. This we have an answer for, right? This is one of the rules. But let's work on that one. Secant cube x dx. So it doesn't look like we could use any of these because n even power of secant we don't have. M is a power of tangent, no tangent. Okay. So what we're gonna do addition by parts. We're gonna split it up, secant x, and then secant square dx. We're gonna let u equal secant x. So du is secant x tangent x dx. dv is secant square x dx. So v is the integral of secant square is tangent x. So u times v minus integral of v du. So u is secant x, v is tangent x minus integral of tangent x, and then du is secant x tangent x dx, which is integral of tangent square x secant x dx, secant x tangent x. Okay. All right, now, so we're gonna do this again. So look what I have. I have integral of secant cube x is this guy minus that. If I change this again into tangent square is 1 plus secant square and multiply that out, what do you get? You'll get integral of secant x dx minus integral of secant cube x dx, which can do the wraparound. We can add that, so we get 2 integral of secant cube x dx equals secant x tangent x minus integral of secant x dx. So integral of secant cube x dx is 1/2 secant x tangent x minus 1/2 secant x dx. So we go back here. So the integral of tangent square x secant x dx equals this guy, which is all this, minus 1/2 integral of secant minus integral of secant dx, which would be 1/2 secant x tangent x minus 1/2 minus 1 is 3/2 integral of secant. We already know integral of secant is ln of value of secant x plus tangent plus c. Why do I have 1/2? I must have messed up my signs. Let's see. Secant x tangent x minus integral of secant q. This should have been a plus right there. So this should have been a plus. And that should have been a plus, and that would be minus 1/2. Okay, fix that please. Okay, example 4. What's the integral of secant 6x dx? Again, this is the case where the power of secant is even, so we're going to split off secant square and apply the relevant identity u equals tangent x. So integral of sec 4x times secant square x dx. So this is secant square x square, which is secant square is 1 plus tangent square. So now we let u equals tangent x. So du is secant square x dx. That's actually why we split it up. That's du, and that's u squared plus 1. So we get u squared plus 1 square du, and then you can integrate this, and you're going to end up with, again, the work is in the notes, but here's the answer. Now, if you want to integrate cotangent cosecant, you follow the same rules for tangent secant. Same rule, and the identity is going to be cosecant squared is 1 plus cotangent squared, as we know. Okay? Same rules, different identity because you have different functions. Now, to evaluate integral of integral of sine mx, no power, okay, like 2x, 3x, sine nx dx, sine mx cosine nx, or cosine mx cosine nx. So basically sine, cosine, or cosine, sine, we use the product to sum identities from trig. To sum identities from trig. And here they are. If you have sine A, sine B, you can write it as 1/2 cosine A minus B minus cosine A plus B. If you have, so we're changing product to sum. If you have sine A cosine B, that's going to change into 1/2. And we proved all these in trig, okay? Plus sine A plus B. And if it's cosine A cosine B, you switch it into 1/2 cosine A minus B plus cosine A plus B. So here's an example, 44, page 499. That's the example that I'm going to do in this section. 44, page 499. How do you integrate sine 2 theta cosine 6 theta d theta? So we have sine cosine, so it's going to be half sine of the difference plus sine of the sum. So it's going to be integral half sine of the difference plus sine of the sum. So I will just pick the 1/2 out. and then integral sine of negative 4 theta d theta plus 1/2 integral of sine 8 theta d theta. Well, sine is an odd function, so sine of negative x is negative sine x, so we can make this and pull it out, the negative. So this would be negative 1/2. Integral of sine is negative cosine, so that's a plus 1/4 cosine 4 theta. That's again negative 1/8 times 1/2 is 1/16 cosine 8 theta plus c. So it's going to be 1/8 cosine 4 theta minus 1/16 cosine oh wait, did I sine A cosine B is 1/2 sine 1/2. Oh, this is not 44. I did something. Let's call this 44 star. 44 has sine. I did sine cosine. It's okay. That's not 44. It's just an example, okay? And you have 44. You can go about doing this. So 1/16 cosine 8 theta plus c. All right. So I did sine cosine. And 44 in the notes, if you can see sine, okay? It's okay, just that's an example, and you can look at 44. And that's it.